Hello everyone, welcome back to my YouTube channel Learn with Sumi. In this video, we are going to see that for what values of lambda and mu, the system of equation x plus y plus z is equals to 6, x plus 2y minus 3z is equals to 10, and x plus 2 plus lambda z is equals to mu. Okay, so in this we have to find like a uniques for what values of lambda and mu. The system of equations is this. So for what values it is going to be a unique solution, infinite solution, and no solution. Okay, so before proceeding with this particular problem, we are going to see what is unique solution, what is infinite solution, and what is no solution at all. It is going to be very easy. Just stay with me till the video ends, and I am sure that you're gonna love it and you're going to understand what exactly these three things means. Okay, so I'll tell you, you do not have to worry if you get in a question what is this unique, infinite, and no solution at all. So I'm just going to tell you what this is. So when we see a unique solution, okay, I'll use a different pen. I have different color pens. Okay, so I'm going to use different pen. So let me see for first unique solution. Okay, something, unique, a different solution, unique solution, you have it here. So I can say tell you that each column has leading one. So we know that this is a system of equation. The system of equation is in this form, right? It is in this form: a x is equals to b, wherein a is a coefficient matrix. A11, A12, A13, A21, A22, A23, and A31, A32, A33. Okay, and x, this is x. So this is some unknown, correct? This is unknown. So let me write it as x1, x2, and x3, which is equals to b1, b2, and b3. This is a constant matrix, this is an unknown matrix or a variable matrix, and this is the coefficient matrix. For your understanding, I will just rewrite it. If you have gone through my previous videos, then you already know this, right? If not, then it's fine. I'm telling you again in this video. This is a unknown matrix or variable matrix, and this is a constant matrix. Okay, so I hope you know this. Now we will see what augmented matrix is. Augmented matrix is nothing but, we have like A is to augmented matrix, B, which is equals to consider C here. The C, this is in the normal form. Okay, so I'll tell you, this is A, this is B, and C is something this itself. Or after evaluating, or after performing some operations in this, we get the values of the unknowns. So that is basically C here, right? So this is the augmented form. Let's forget this for now. This is the augmented form. So I'll just write the augmented form here to explain you what is unique and no solution and infinite solution. So I'll write the augmented form: A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, now I have to write here all the B's. Okay, B1, B2, and B3. So when I told you about a unique solution, I also said each column has leading one, right? each column has leading 1. So I will rewrite this matrix and explain you what it is saying. Okay, 1 started with 1, 0, 0. Okay, done. Consider some values here. 0 leading 1, 0. Consider values here. 0, 0, 1. Okay. So if you see here in the each column we have the leading 1. Okay. And this, the other half of the matrix is non-zero, right? It is non-zero or anything, non-zero or 0. Okay, non-zero or 0, it doesn't matter. But if you see, if you multiply, let me consider this is the coefficient of x, right? So x1, x2 and x3, I'm writing it here. So here if you go directly, x1 into 1, which is equals to b1. Let me give this some value 1, 2 and 3. It can be the same only, 1, 1, 1 or 1, 2, 3 or 1, 3, 3, 3, 3, 3, 2, 2, 2, anything, but some unique value. Okay, b1 which is equals to 1. x1, x2 here x2 into 1 which is equals to b2 which is equals to 2, and x3 into 1 is equals to b3 which is equals to 3. Okay, I'm just taking it here for your understanding. So this is going to give me x1 is equals to 1, x2 is equals to 2, and x3 is equals to 3, right? So this is a unique matrix, right? So if you ask me what is the value of unknown, so I can tell you it is 1, 2, 3. x1 is equals to 1, x2 is equals to 2 and x3 is equals to 3. So this is a unique matrix. You have a unique solution for this matrix. Hence, you know how to find a unique solution. Now let me tell you how to find, I'll go with first, what? No solution. No solution. I will explain you in a very simple words. Okay, consider this is a left side of a matrix. Okay, left side for your understanding. I will just refer it as left and right side, and this is right side. Okay, so left side, because for your understanding I'm just writing this as left and right side. So left side has 0 row, but right side has a non-zero value. Okay, so see this is the 0 row I have, but here this is some non-zero value. Okay, consider this is 1, 2 and again 3. This is a non-zero value, something minus 3 plus 3, anything, but not a 0. This is anything but 0. But we have a 0 row, correct? In a no solution, if we get a 0 row, but we have got some value on the right side of a matrix, this is the right side. Okay, then we can say we have got no solution at all. So again I'll tell you, this is x1, coefficient of x1, x2 and x3. So here if I do this, x1 into 1 is equal to 1, x2 into 1 is equals to something 2, but x3 is multiplied to what? 0 only, and which is equals to b3, which has some value 3, or 4. It could be anything but a non-zero value. So 3. So 0 multiplied to anything, it has to be a 0 according to whatever we have learnt it from our childhood. Okay, but it has got some non-zero value. So this is impossible, right? This is impossible. So hence we say no solution. Now we have got one more. we have got one more, infinite solution. Okay, infinite solution. So for this also, I'll write the matrix and I'll come and explain it to you. So if you see this matrix, I have 0 row, 0 row, and the right side is also 0, right? If we have a 0 row, complete 0 row, complete 0 row, both sides, I am referring to left side and right side. Okay, this is left side, this is right side, both. So I'll tell you how. This is, again, we know coefficient of x1, x2 and x3. So here I'm going to get x1 is equals to some value b1, x2 is equals to some value, let me consider 1, 2, 3 again. So b2 is equals to 2. Here x3 multiplied to 0, giving me 0. So here x3 can be anything, right? Anything. 1 into 0, 0, 2 into 0, 0, 3 into 0, 0, 4 into 0, 0, minus 3 into 0, 0. Anything at all, anything at all. This can be any non-zero value which will give me 0 here. So I can say that I have the infinite number of solutions, infinite number of solutions. I hope this is clear now. I hope this is clear now. Unique solution, you have got all the leading ones in every column, all the leading ones in every column. No row is a 0 row, no row is a 0 row. Everywhere you have got a leading one. Okay, and you get a unique solution for this x1, x2 and x3. No solution, you have got a left side as a 0 row, but a right side have got some non-zero value, which makes, no sense to me. I don't know how it is, but okay, you have got a 0 row, but this is a non-zero value. So this is consider 1, 2, 3. So you're multiplying anything with any number, any non-zero number, you should get 0, but you're getting a non-zero value, which is impossible. So there is no solution for this. Then I have got a infinite solution wherein you have got an entire 0 row on the both left and right side, and in the other 2 rows, okay, leading ones you have got. So 1, 2, 3. So here also you can see the coefficient is multiplied to the 0 and it is giving you 0. So the coefficient can have n number of different values, infinite solution, infinite values. So we are saying this is an infinite solution. So now let's move to the question what we were about to solve, right? Okay, this is little so this is the question we were about to solve. Now we know what is unique, infinite and no solution, right? We know this. Now that we know what this means, we will find unique, infinite and no solution for any values of like x, y. We will find what values of x and mu we are going to have these cases. So let me write the system of equations, that is what ax is equals to b, right? So system of equations, I'll write it 1, 1, 1, okay, 1, 2, minus 3, 1, 2, minus 3, and then I have got 1, 2 and lambda. Now unknowns are what? X, y and z, which is equals to a constant matrix, which is nothing but 6, 10 and mu. So this is a system of equations which can be written as the augmented matrix, that is going to be 1, 1, 1, 1, 2, minus 3, 1, 2, lambda, right? 6, 10, mu. Now we will perform some elementary row operations, okay? Some elementary row operations. Consider this is the Gauss's elimination method. So echelon form. Okay, so we are going to have the upper triangular matrix. Okay, upper triangular matrix. So reduced matrix or reduced matrix into, matrix, it is getting reduced to the upper triangular form matrix. Now this is going to be, I am performing some operation in this matrix so that these elements, these three elements or numbers becomes 0. I have to perform some elementary row operations. Okay, so this is a leading one. Okay, I want to make this as a leading one but this as a 0. So let me perform like R2 row 2 changes to row 2 minus row 1. Okay, so row 1 I will write it as it is. Okay, row 1 I will write it as it is. Row 2 is row 2 minus row 1. So that is going to be 0. 2 minus 1 is 1. Minus 3 minus 1 is minus 4 is 2. 10 minus 6 is what? 4. And here also I have to perform some operations. So I will change row 3 to row 3 minus row 1. Okay, so this becomes 0. 2 minus 1, 1. Lambda minus 1, it is going to be what? Lambda minus 1 only. Correct? This is a row 1. Now this is going to be mu minus 6. Correct? Now I will perform some operations here to make even this as 0. Even this as what? 0. So I can do something as, let me just write this 2 rows as it is. I do not have make any changes to. Now row 3 I will change to row 3 minus, this I want to make it 0. So this is I can do like a row 3 minus row 2. If I do this operation, perform this operation, it will become 0. 1 minus 1 0, 0 minus 0 0, 0 minus 1 1 minus 1 0. Correct? And now lambda minus 1 minus, this is going to become, I'll just show you here what it is going to become. Okay, lambda row 3 minus row 1, right? Minus 1. Okay, minus 4. So lambda minus 1 plus 4, this is going to become lambda plus 3. This is minus 1, this is plus 4. So this is going to become what? Lambda plus 3. Okay, so lambda plus 3. Now this is going to be mu minus, this is what? Mu minus 6 minus 4. So this is going to be mu minus 6 minus 4. This both we will add it, mu minus 10. Right? So this is going to be mu minus 10. Now that we have lambda plus 3 and mu minus 10. So we know like what are the for unique solution. For unique solution, we should have like all leading ones, right? I will write it here. Unique solution. In order to find the unique solution, we should have leading one in all rows, right? Leading one in all rows, which means it should be something like this. Okay, for your understanding, I'm writing this. Some value here, A, B, C. Okay, any value here, A, B, C. So I can say for a unique solution, lambda, which is not equal to, here it is what? Lambda plus 3. If it is not equal to minus 3, right? If it is not equal to minus 3, So for lambda not equal to -3, I can say, because it is going to be like it should be a non-zero value. So lambda plus 3 we have, it should be not equal to -3, and mu -10 it is, right? So mu not equal to 10, then it may have a unique solution, right? Now let me see for infinite solution. For infinite solution, what it should be? For infinite solution, this should be 0, this should be 0. So for lambda is equals to -3, plus 3 minus 3, it will be 0, this will become 0, and mu equals to, for infinite solution we should have something here, we should have like 10, 0. This also we should have 0, right? Infinite solution, it is like this. The entire row for infinite solution, entire row is 0, entire row is 0. This is like, consider this 1 2, but this is entire row is 0. So -3 and 10. Then system can have, okay, I'll write it, have infinite solution. Okay, now for the third one we have something, what do we have? Unique solution. This is infinite solution, and first then no solution, right? No solution. So for no solution we should have like, what is the condition? Left is row, it is entire 0, but it has got some value, non-zero value here, right? So 1 0 0 0 1 0 0 0 0 a b, and this is also some non-zero value, right? So I can write like, for lambda is equals to -3 and mu not equal to 10, the system of equation may have no solution. For these values, the system of equation may have no solution. Thank you so much for watching this video. I hope the concept is clear now. If you have understood this very well, do not forget to share it with your friends, okay? And share, subscribe, like, comment, do as much as you can, so that I can grow, my channel can grow, and I will be motivated to help you all. Thank you so much.